Hello everyone, welcome to my channel. Myself Vignesh Anand. In previous video, we are discussion about the brushless and coreless motors. So in this video, we are going to have a small discussion on the brushed DC motor. In that, particularly separately excited DC motors and permanent magnet DC motors will be explained in this video. So coming up to the topic now. Normally, the permanent magnet DC motor, in the sense, the motor has a permanent magnet in the inner periphery of your stator. The magnetic field required to produce the rotating torque is developed by the set of permanent magnet. The magnet are radially magnetized inside the yoke, which means your outer frames inside the magnet will be magnetized. The stator is used to carry the magnetic field produced by the magnet. The rotor consists of a armature core, armature winding, commutator and brush alignment in order to carry the current to the motor. So as like a normal DC motor, it has a stationary part and a rotatory part. Next, coming up to the working principle, when a carrying conductor comes inside a magnetic field, a mechanical force will be experienced by the conductor, and the direction of the force is governed by the Fleming left hand rule. The armature is placed inside the magnetic field of a permanent magnet, so the armature rotates in the direction of the generated force. Next, each conductor of the armature experiences a force, and the completions of this force produce a torque which tends to rotate this armature. Because of the absence of the field winding, it does not require a excitation current for the field winding, so automatically which reduces the losses, like kind of a hysteresis losses will be very much reduced. Next, we will see one small example of your permanent magnet DC motor. So this is the overall structure of your permanent magnet DC motor. In here, the field magnet, which is surrounded by the armature, and the external DC supply is given to your armature, and further the process, which means your conversion of electrical to mechanical energy, will takes place. So this is the overall structure of your permanent magnet DC motor. As I said, the frames which is covered outside of your motor, then the stator magnet which is placed or fixed with the uh, yoke or the frames. So in order to uh, give a path for your magnetic field. Next is your rotor, which means your commutator, which is fixed with your shaft, and then the armature windings and the armatures are being placed, and then the commutator is connected with your brushes, and further the DC current will be given to the load. Next, advantage of your permanent magnet DC motor, there is no need of a field excitation arrangement, and no input power in consumed for excitation, which improves the efficiency of the DC motor. Then no field coil, hence space for the field coil is saved, and the overall size will be get reduced, and it is cheaper and economical for the fractional kilowatt rated applications. Then disadvantages, the armature reaction of the DC motor cannot be compensated, hence the magnetic strength of your field may get weak due to the demagnetizing effect of your armature reaction. Then there is an absence, which means there is a chance of getting the poles permanently demagnetized due to the excessive armature current due to the starting or reversing overloaded conditions of your motor. Then the field in the air gap is fixed and limited, so speed control is not possible in this permanent magnet DC motor. Some of the example of your applications, it is mainly used in your automobiles for wipers, washers, blowers, air conditioners. then it is used in your disk drives in a personal computers, then used for your electric toothbrushes, then for the portable vacuum cleaners, it is used in your food mixers industries, then used for your portable electrical tools such as drills, saws, trimmers. Then this is your physical structure of your permanent magnet DC motors. So physically the permanent magnet, commutator, armature and the brush contacts are been shown here. Next, coming up to the separately excited DC motor, the supply is given in separately to the field and the armature winding. That's why it is known as your separately excited DC motor, because the field and the armature windings are separately exciting or excitation carried out. So the armature current does not move around the field windings, as the field winding is powered from a separate external source of DC. Then the torque, it is given by the formula Ka. Ka is your constant and phi is your magnetic flux or field. Then Ia is your armature current. So the torque is changed by the modifying the field, which means your magnetic field flux, and it is independent of your current of the armature. So the torque is directly proportional to their magnetic field. Then working principle, the fixed stator and the cylindrical rotor introduces as a armature. The rotor and the pole shoes are always connected in order to decrease the iron loss waste caused by your varying magnetic flux, and the poles are connected with the field winding, moving the field current, that is, which runs the main flux around the rotor and the stators. A closed armature coil is set in the axial slots of your rotor and combined with the commutator bars. It is provided by the brushes and the commutator produces the armature current. So this will generate a mmf, and so that the maximum output torque for the armature current can be created by this operation. So the principle of commutation is very simple. Here the closed armature structure of two pole DC motor is generally performed providing the brush position at a two consecutive instants of your time, which means the brush position will changes according to the pole changes. Then speed control of your separately excited field DC motors. In here we have a three types of speed control. One is with the field control, second one is with your rheostat, and another one is with your armature control. So first, field control. The reduction of the field increases the speed of your device, while improving the field cause reduction in the speed. So automatically speed will be inversely proportional to the field. So the speed regulations of this type of motor can be uh, obtained by controlling the field of your motor. Next, second type is with your field rheostat control. In here, a variable resistance is arranged in a series form with the field coil. So therefore the speed is determined by variation of your flux. Then another type is with your armature control. In here we have a two type of armature control. One is with the armature resistance control, second one is your armature terminal voltage control. So armature resistance in the sense same kind of a field rheostat. In here the speed is determined by changing the source voltage to the armature. So typically a variable resistance is used in the armature to change the armature resistance. Next is with the armature terminal voltage control. In here it is used to change the voltage in the armature circuit. Automatically changing the voltage will cause the speed control of your motor. Next, this is your practical example. So in here we have a two supply. One is for your armature supply, second one is for your field coil supply. So this is how the working takes place in your separately excited DC motor. Next, we will see some of the applications for your separately excited DC motor. So typically it is used for your actuators. Then it is employed for your some of the real-time examples like a train and for your automatic traction machines. These are all the basics of your permanent magnet and the separately excited DC motors. So hope you understand. I think so. In coming up video, we will have a short discussion about your self-excited motor and their types. Have a nice day. Nandri Vanakkam.